In this episode, we're going to make a big idea feel practical. How to use control thinking in a style similar to control objectives for information and related technologies, COBIT, to manage AI risk in a way that is clear, repeatable, and defensible. New learners sometimes think controls are only technical locks and alarms, but controls are broader than that because they include the rules, reviews, evidence, and accountability that shape how work actually happens. AI creates risk partly because it is easy to adopt quickly and partly because the results can feel persuasive even when they are wrong, which means control thinking is one of the fastest ways to bring calm discipline to AI use. The goal today is not to memorize a framework name or a set of formal statements, but to learn how to think in a COBIT-like way. Define objectives, establish practices that achieve those objectives, and approach assurance as the discipline of proving controls are working. When you can do that, AI risk management stops being vague and becomes a system you can explain to leaders and apply consistently across many use cases. By the end, you should be able to translate an AI scenario into a control objective, describe practices that support it, and explain what evidence would show the control is effective. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at Cyber.Author.me in the Bare Metal Study Guide series. A good starting point is to understand what control objectives mean in plain language, because the phrase can sound intimidating when you first hear it. A control objective is simply a statement of what you want to be true, even when people are busy, tools change, and pressure to move fast is high. For AI, a control objective might be that only approved AI use cases influence high-impact decisions, or that data sent to AI tools follows strict rules, or that AI outputs are monitored for drift and harmful patterns. The objective is not the same as the method because the objective describes the desired outcome, while practices describe how you achieve it. This separation matters because objectives should remain stable over time, even when tools and models evolve. If your objective is clear, you can change the practice as needed without losing control, which is essential in AI because capabilities and vendor features shift quickly. Beginners often jump straight to solutions, like saying we need monitoring. But an objective-first mindset forces you to clarify why monitoring is needed and what it must accomplish. That clarity makes governance easier, because you are no longer debating preferences, you are aligning around outcomes. Once you understand objectives, the next step is to see what practices are, because practices are where control thinking becomes real work. A practice is a repeatable action or requirement that, when performed consistently, makes the objective more likely to be achieved. If the objective is that AI use is approved and documented, then a practice might be a formal intake and review process for new use cases, with clear decision rights and required evidence. If the objective is that AI does not create unacceptable fairness harm, then a practice might be evaluating outcomes across relevant groups and documenting results and limitations. If the objective is that AI use does not leak sensitive data, then a practice might be restricting which tools can be used and defining what data types are permitted as inputs. Practices should be specific enough that different teams can follow them consistently, but not so narrow that they become obsolete when tools change. This is why COBIT-like thinking is useful for AI, because it encourages practices that are grounded in governance and accountability, not just in one vendor product. For beginners, it helps to remember that practices are how you turn policy words into day-to-day behavior that can be checked and improved. Now let's talk about assurance thinking, because assurance is the part that makes controls credible instead of theoretical. Assurance is the discipline of gaining confidence that controls exist, are operating as intended, and are producing the desired outcomes. In everyday terms, assurance means being able to prove, not merely claim, that the organization is managing AI risk responsibly. AI is a domain where claims can be especially misleading because a system can appear to work until it suddenly fails, and because teams can believe they have controls when controls are inconsistent or bypassed. Assurance involves asking what evidence exists, how reliable that evidence is, and whether evidence is reviewed on a predictable cadence. It also involves being skeptical in a healthy way, because good assurance does not assume people did the right thing. It checks that they did. This is not about distrust. It is about protecting the organization from the gap between intention and reality, which is where risk grows. If an executive is asked whether AI use is controlled, assurance is what allows them to answer with confidence and documentation instead of with hope. For exam purposes, assurance thinking often separates strong governance answers from weak ones because it focuses on proof and repeatability. A useful way to apply COBIT-like control thinking to AI is to start with a small set of high-level objectives that cover the main risk pathways. One objective is clarity of purpose and ownership, meaning every AI system has a defined intended use, a defined set of boundaries, and named accountability for outcomes. Another objective is controlled adoption, meaning AI use cases enter through an intake process, are classified by impact, and receive appropriate review before they influence decisions. Another objective is responsible data handling, meaning data used by AI is appropriate, lawful, and protected, and data flows are documented and monitored. Another objective is outcome reliability, meaning performance and harmful patterns are evaluated before deployment and monitored after deployment, with triggers for intervention. Another objective is defensibility, meaning decisions are documented, evidence exists, and the organization can explain what it did and why. Notice that these objectives are not tied to any one model type, because they apply whether the AI is an internal system or a vendor feature. They also connect directly to the harms we discussed earlier, because objectives are designed to prevent money loss, safety harm, trust erosion, and legal exposure. Beginners should see that a small number of clear objectives can govern a wide variety of AI uses, which is what makes control frameworks powerful. From there, you choose practices that support each objective, and this is where your earlier lessons on inventory, classification, and documentation become part of a coherent control system. If the objective is controlled adoption, a key practice is maintaining a complete inventory of AI systems and features, including vendor capabilities and shadow AI. That inventory practice prevents blind spots, because you cannot govern what you cannot see. Another practice is impact classification, which ensures high-impact uses receive stricter review and stronger oversight than low-impact uses. A third practice is required documentation, including intended use, data sources, evaluation results, approvals, and monitoring plans, because documentation is how you preserve accountability and prove responsible decisions. These practices work together because inventory reveals what exists, classification tells you what matters most, and documentation captures the evidence and decisions that make controls defensible. If any one of these is missing, the control system becomes fragile, because teams will either miss risky systems, apply the wrong oversight level, or be unable to prove what they did. This is why framework-style thinking emphasizes completeness and connection rather than isolated tasks. For beginners, the big takeaway is that controls reinforce each other, so you design them as a system, not as a pile of disconnected requirements. It also helps to understand that COBIT-like controls often focus on decision discipline, because decisions are where risk enters the organization. For AI, important decisions include approving a use case, approving data sources, approving deployment, approving changes, and approving exceptions when requirements are not met. A good practice is to define decision rights clearly, so teams know who has authority to approve and who has authority to block. Another practice is to define minimum evidence required for each decision, so approvals are based on criteria rather than persuasion. Another practice is to record decisions, including conditions attached to approval, such as requiring human review for high-impact outputs or limiting the AI to advisory roles. These practices create predictability and reduce shadow behavior because people can see a clear path to doing things the right way. They also support assurance because auditors and leaders can review decision records and see whether governance is operating consistently. Beginners sometimes assume decision discipline slows innovation, but in healthy organizations it speeds innovation by reducing confusion and rework. When the decision process is clear, teams can plan and deliver without last-minute surprises. Another major area where control thinking adds value is data governance, because AI systems often expand data use in ways that are not obvious to end users. A control objective here might be that AI use respects privacy commitments and minimizes data exposure, especially when data flows to vendors. Practices that support that objective include restricting which AI tools are approved, defining what data types are permitted as inputs, and requiring documentation of data flows and retention behavior. A related practice is ensuring that data used for AI is accurate enough and representative enough for the intended purpose, because poor data quality can create unfairness and unreliable outcomes. Another practice is defining how sensitive data is protected, including access controls and oversight for who can enable AI features that ingest data. The reason this fits the COBIT-like style is that it emphasizes consistent governance outcomes rather than ad hoc individual judgment. When data rules are clear, employees do not have to guess whether a shortcut is acceptable, and the organization reduces the risk of accidental disclosure through casual tool use. For beginners, it is important to see that data controls are not only technical, they are behavioral and procedural, shaping what people are allowed to do and how they are trained to do it safely. Outcome controls are another area where AI requires special care, because AI is not only about correct behavior at launch, but about ongoing reliability as the environment changes. A control objective might be that AI systems remain within defined performance and fairness tolerance over time. Practices that support this include evaluating performance before deployment in the real decision context, monitoring for drift and harmful patterns after deployment, and defining thresholds that trigger review or pause. Another practice is requiring human oversight in high-impact uses, meaning humans remain accountable for final decisions and have the authority to override or escalate when outputs seem risky. Another practice is incident management specific to AI, where harmful outputs are reported, investigated, and used to improve controls. These practices are important because AI can fail quietly, with small errors accumulating until harm becomes severe. Monitoring and escalation are how you detect that quiet failure early. Assurance thinking then asks whether monitoring actually happens, whether thresholds are realistic, and whether the organization acts when thresholds are crossed. Beginners should recognize that a monitoring plan that nobody follows is not a control, it is a document, and assurance exists to catch that gap. Vendor and third-party controls deserve explicit attention because many organizations rely on AI through external services where internal visibility is limited. A control objective might be that vendor AI services are used responsibly and that vendor limitations do not undermine the organization's obligations. Practices that support this include documenting vendor AI capabilities, documenting what data is shared, clarifying responsibilities in contracts, and requiring evidence from vendors about limitations and appropriate use. Another practice is controlling who can enable AI features in vendor platforms, because default settings and feature updates can introduce new AI behavior without deliberate approval. Another practice is requiring that vendor AI use cases still go through internal governance review when they influence high-impact decisions, because vendor ownership does not remove organizational accountability. Assurance thinking for vendors asks whether the organization can prove it reviewed vendor risks, whether it knows where data flows, and whether it has a plan for monitoring and responding to issues. Beginners often assume vendor products come with built-in safety, but the organization still must manage the risk of reliance on those products. Control thinking makes that responsibility explicit and consistent, which reduces the chance of hidden AI adoption through procurement and platform upgrades. To make all of this more concrete, imagine a scenario where a team wants to use AI to prioritize customer complaints. A COBIT-like objective might be that high-impact customer issues are not missed and that decisions are transparent and auditable. Practices could include classifying the use case as higher impact because it affects safety and trust, requiring documentation of intended use and limitations, and requiring human review for complaints tagged as potential safety issues. Evaluation practices would include testing how often urgent complaints are misclassified and documenting error patterns. Monitoring practices would track misrouting rates and complaint escalation outcomes over time, with thresholds that trigger review. Assurance would involve periodic checks that monitoring reports are produced, that exceptions are documented, and that any incidents are investigated and used to improve controls. Notice how this approach does not require advanced math, but it does require disciplined thinking about objectives, practices, and evidence. The value is that leaders can defend the approach because it shows deliberate choices, clear boundaries, and ongoing oversight. For beginners, this example shows how framework-style control thinking becomes a practical recipe for responsible deployment. Another important element in assurance thinking is maturity, meaning controls can exist at different levels of completeness and reliability. In early stages, an organization might have informal practices, like teams documenting use cases in different ways, which provides some evidence but creates inconsistency. As maturity grows, documentation becomes standardized, decision rights become clearer, monitoring becomes routine, and exceptions are managed through defined approvals. The purpose of seeing maturity is not to judge organizations, but to guide improvement in a realistic way, because not every organization can build perfect controls overnight. A COBIT-like mindset supports incremental improvement because it encourages you to define objectives first and then improve practices and assurance over time. For exam reasoning, maturity thinking helps you choose answers that build sustainable control capability rather than quick fixes that do not scale. It also helps you see why certain controls should be prioritized, such as inventory and documentation, because they enable almost every other control. Beginners should understand that assurance is not a one-time audit event, but a continuous habit of verifying that controls are operating as intended. When that habit exists, the organization becomes resilient and less likely to be surprised by AI risk. As we close, the main message is that COBIT-like control thinking gives you a disciplined way to manage AI risk that is stable even as technology changes. You start by defining clear objectives that describe what must be true for AI use to be responsible, such as clear ownership, controlled adoption, responsible data handling, reliable outcomes, and defensible decisions. You then define practices that make those objectives real, including inventory, impact classification, required documentation, decision rights, monitoring, incident management, and vendor oversight. Finally, you apply assurance thinking to prove controls are working, using evidence, periodic checks, and clear accountability when gaps are found. This approach reduces reliance on personality and improvisation because decisions are guided by objectives and supported by repeatable practices. It also strengthens leadership confidence because leaders can explain not only what they decided, but how they know controls are operating. When you can think this way, AI governance becomes both practical and defensible, which is exactly what Domain 1 expects you to understand before moving deeper into program execution details.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.